Hello students, so we have started with the topic probability and let's learn the new subtopic, that is random variable and its probability distribution. Okay, so what is random variable? A random variable is a real valued function whose domain is the sample space of random experiment. Okay, if you are doing any random experiment, when you take its domain, that becomes the sample whose domain, this random variable x is the function. Okay, so whose domain is the sample space of a random experiment. So let's learn through an example. Okay, so codomain is any real valued function. Okay, a real valued number, so set of real numbers. So if you have, say, tossing a coin twice, okay, so its sample space will be what? Head head, tail tail, head tail, or tail head. Okay, so a random variable is a real valued function whose domain is the sample space. So this becomes the domain of the random variable. Okay, which is a function. Suppose x, it is denoted by x. Okay, so I will take x, which is a function, number of heads obtained. Okay, so we have a domain and a codomain. Domain is this sample space, right? And this is our function x, which is a random variable. So the codomain set will be what? So x of HH, that is number of heads obtained, here is 2, right? Then number of heads obtained, HT will be only one head is there, so 1. Okay, so TH will be 1 and here will be 0. Okay, so we have x of HH, that is heads are 2, that's why this number. Okay, so this is your codomain set. Okay, it is a set of real numbers. Okay, it can be anything, any number. So now you know what is a random variable. So second example we can take, that is y denote the number of heads minus the number of tails. So suppose I am taking y as number of heads minus number of tails. Okay, so now our random variable is y. Okay, so y of HH will be what? Number of heads minus number of tails. Here number of heads is 2, number of tails is 0, so your answer will be 2. Okay, y of HT, number of heads is 1, number of tails is 1, so 1 minus 1, this is 0. Y of TH will be again 0 and y of TT, so here number of heads is 0, number of tails is 2, so this will be 2. Okay, now let's write the probability distribution. Okay, so I will write for x, that is random variable x. Okay, now we know the sample space has elements HH, TT, HT and TH. So probability of getting head will be what? So this is for the first toss, I am getting head, so it will be probability of getting head and head, right? Head and head. So this will be half we are tossing a coin for the first time. So probability of getting a head at that time will be half, right? Into again you are getting head, so half. So it is 1 by 4. Okay, P of HH is 1 by 4. Then P of HT will be what? This is head and tail. Again the same thing, because head also half and tail also half. Okay, 1 by 4. Okay, now if you have to write probability together, that is HT or TH, that is when the random variable is 1. For both this it is 1, right? So I'm going to write HT or TH. So this will be whenever OR is there you have to add. Okay, whenever OR is there you have to add, and whenever AND is there you have to multiply. So here it will be HT is 1 by 4, right? And OR means 4 plus. So this is also 1 by 4. So together it will be 2 by 4, which is again half. Okay, let's write it in the form of a table. Okay, so I will write it here only. X P of X. So value of random variable X is 0, value of random variable 1, and value when it is 2. Okay, when it is 0 we are getting tail and tail. Tail is half and tail. So this comes to 1 by 4. Okay, then whenever random variable X is 1, 1. Okay, so here it is this one, that is HT or TH. So answer of this, that is probability of HT, is half into half, that is 1 by 4, right? So we'll have to add 1 by 4 or TH, that is 1 by 4. So it is 2 by 4, so it comes to 1 by 2, or you can write here 2 by 4 also. Okay, or it is half. For 2 it is HH, right? So again half into half, so it is 1 by 4. Now let's check whether the addition of all these probabilities is 1 or not. It should be 1, because this is based on single event, that is probabilities in a single event, tossing a coin twice, right? So let's add P of 0 plus P of 1 plus P of 2. So it is 1 by 4 plus 2 by 4 plus 1 by 4. So this comes to 4 by 4, which is 1. So we are right. Okay, so it should be 1. Summation. So we write probability distribution of a random variable of the system is the system of numbers. Okay, so we write summation I from 1 to n P of xi. Okay, and it should be equal to 1. Now let's solve some examples. Question is, a person plays a game of tossing a coin thrice. For each head he is given ₹2 by the organizer of the game, and for each tail he has to give ₹1.5 to the 1.50 to the organizer. Let X denote the amount gained or lost by the person. So our random variable is the amount which is gained or lost by the person. Now X is a random variable and exhibit it as a function on the sample space of the experiment. So sample space here, now coin has tossed 3 times, right? So sample space will be HHH, TTT, HTT, THH, TTH, THT, HTH, 1 2 3 4 5 6 7 and one more. HTH, THH, HTT, THT, TTH, okay, and TTT and HHT. Okay, so this becomes the domain for the function that is X random variable. Okay, now sample space is this. So you have to find the amount gained or lost by the person. So whenever he gets a head, for each head he is given ₹2, and for each tail he has to give ₹1.50. So you have to minus that sum. Okay, so X of H will be what? Now 3 heads are there, right? So he has to give ₹2, ₹2 and ₹2. So total amount will be 2 into 3, right? So it is 6. For X HHT, which is also same as HTH, which is also same as, that is for 2 heads and 1 tail, which is also same as THH, right? So this will be ₹2, and tail you have to minus 1.5. Okay, so 2 heads are there and 1 tail is there, so we'll be doing 2 heads into 2, that is rupees, minus 1 head into 1.50 you have to do. So 4 minus 1.5, so it comes to 2.50. Okay, then we have for 1 head and 2 tails, 1 head and 2 tails, 1 head and 2 tails. Okay, so 1 head, that is 2, tail is 1.50, 1.50. Okay, 1 head, 1 into 2 and minus 2 into 1.50. Okay, so is to give minus 1. Then for all the tails is 1.5, 1.5, 1.5. So he has loss of 3 into 1.50. So 4.50 minus. Okay, so this is the random variable and values. Okay, and then you have to find the probability. I'll just write the probability of HHH, what it will be. So for the first head it is half, for the second head it is half, for the third head it is half. So half into half into half, so it is 1/8. Okay, similarly for HHT, or that is for the second case, HHT or HTH or THH, this will be, this or is there, so you have to add. So this is 1/8 plus 1/8 plus 1/8, so it comes to 3/8. Okay, so that will be the probability distribution. Okay, let's do one problem for probability distribution. So 2 cards are drawn successively with replacement from a well shuffled deck of 52 cards. So we are drawing 2 cards from 52 cards. Okay, find the probability distribution of the number of aces. Okay, so see, 2 cards are drawn. So what are the possible outcomes? So either both the cards will be ace, right? So this will be X of ace, or it will be 1 ace and other one non-ace card, or it is ace, non-ace card and ace card, or both are not ace cards. Okay, this will be the possibilities for random variable. So both the ace means it is 2, this is 1, this is 1, and this is 0. So we have x values 0. I will write here the table. Okay, so we have to find P of probability. So x can take values of 0, 1 and 2. Okay, 1 will be for an or na. Okay, so let's find out P of 2, which is both are ace cards. Okay, so both are ace, so it will be both ace, ace and ace. Okay, so ace, if you take one card, okay, from the deck of 52 cards, so possibilities of getting a ace will be 4 by 52, correct? And it is given in the question that with replacement, now we are replacing that card, so the total number remains the same. So again we'll get the 4 upon 52, so it comes to 1 upon 169. Okay, and it is 16 upon 169. Okay, so this is ace and ace. Then second is our probability of 1, which is P of either ace or ace and non-ace. Okay, ace and non-ace plus, that is, or probability of non-ace and ace. Okay, so ace and non-ace. Ace, it is 4 by 52. Non-ace cards are here to minus 4 out of 52. So 52 minus 4, it is 48. So 48 by, we have 48 possibilities. So 52 plus, again non-ace is again 48 by 52 plus 4 by 52 into. Okay, so it comes to 144 upon 169. So this way you have to find. Okay, so here it will be 1 upon 169. For 1 it is 24 upon 169, and for 0 it is 144 upon 169. Okay.